So here we are looking at the unit circle, and I'm going to start at an arbitrary point. I'm going to start at a nice one that is just everywhere. So this first point right here. If this is the unit circle, what's the radius of that circle? 1, says Abijah. Okay, which means if I were at the origin and I went 1 over, what's this new ordered pair? 1, 0. Now, we have that ordered pair there. I'm going to go through, I'm going to do all the points first, and then we'll come back through and we'll do all the radians. Okay, so first thing, this point, and this is always a strange question. If you want to draw the bow ties and butterflies, you can. But here's my question about this point, and it's always going to be my question. Is this further to the right, or is it further up? It's further to the right. And what are the 3 possibilities anywhere in my circle that I get for the numerator? Root 3, root 2, or root 1? Which one's the biggest out of those? 1 won't count because it's all these quadrants, but that's a good thought. Yep, 1 is the same. Root 3, root 2, root 1. Which one's the biggest? So do you guys agree that this is further right? It better be root 3 for the x. Now, this is that countdown thing that I had. If we want, and when I do the unit circle, I legitimately do it like this. I just start with the x's. Root 3 over what? 2. And then let's just start counting down. I'm not going to pay attention to any of the y's yet. Root 3, root 2, root 1. And I'm not even going to call it root 1, but it is root 1, right? 3, 2, 1. And then we can hit this top point. What's this ordered pair up here? 0, 1. Now, if you can do 3, 2, 1, you can do the whole circle. Like that is legitimately, I'm not even exaggerating, that is it. If you can count down from 3, you're golden. 3, 2, 1. Now, this 60 degrees right here is the same as this 60 degrees. It's just coming from the other side. These triangles are the same, which means if this is 1/2 over, this is 1/2 over. But because we're in quadrant 2, where is it? Negative. So 3, 2, 1, negative 1, negative 2, negative 3. We have all the x's for my top quadrants. Okay, do I have to keep talking about it in as much detail? Can we just say the bottom is going to do the same? We'll just do the top part. Okay, last one here. What's this ordered pair? Negative 1, 0. Awesome. So, Davian, you were not here on Friday. Did you watch the video by chance? You need to. I'm pretty sure. I don't know. Have you seen the unit circle? You definitely watch a video then. Cool. All right. Or come to study hall or both. Now, for this, 3, 2, 1, 1, 2, 3. Now, what's nice about this is that root 3 over 2 will always pair up with the counterpart. It'll always pair up with the smallest, right? This is the smallest way up. What's the smallest value of these 3? So when we switch to the y's, and I legitimately go through the whole x, and then I go through all the y's. So I start, instead at 3, I start at 1, 2, 3. And I just switch the order. Now instead of counting down, I'm counting up. 1, 2, 3, 3, 2, 1. The biggest mistake and where I steal points from people on this is signs. You need to know where you're positive, where you're negative. But most of the time, people can do this no problem. If you missed a sign, I count you wrong. There's 36 points on your quiz. There's 24 points and 12 angles. It might actually be 18 points and 16 angles, but whatever it is. Okay. Does your unit circle look exactly like this? Perfect. Now down here, the same thing. I'm not going to do everything, but if we're looking at the x's, 3, 2, 1, 1, 2, 3. What's this one? 3, and it's negative, right? Okay, and then over here is 1, and we're back to positive. Okay, I'm not checking your whole unit circle. You can check it against the cheat sheet that I just gave you. Do I need to talk further about these? Okay, count down from 3. As long as you remember that it starts at 3 over, we're golden. Okay, the radian stuff is kind of intimidating, but it doesn't have to be. And we actually spoke about this one a little bit a couple weeks ago, like 3 weeks ago at this point now. But okay, 30 degrees. Can you guys count by 30s? Can you skip count? 30, 60, 90, 120, 150, 180, right? You can do that. I don't know why there was that song to it, but it happens. Can you skip count by thirds? 1/3, 2/3, 3/3, 4/3. Again, the same song for whatever reason. 30 degrees. How do I convert degrees to radians? So if we have to do this once, we can. Or I can just ask you, if I know that this is half a circle, how many radians is half a circle? Pi. And 30 degrees is how much of a half a circle? 1/6 of it. So can we all agree that without doing the conversion stuff, that this is pi/6? Okay. So when you guys write these all down, and you won't have to do this every time, but I'm just going to write them on the inside here. But I think we can do it. Check this out. This is pi/6. Let's jump to the next 30 degrees. It's now 2 pi/6. Here's another 30 degrees, 3 pi/6, 4 pi/6, 5 pi/6, and 6 pi/6. Now, there's one little annoying thing about this. What is it? I did not simplify them yet, but we can do that after the fact. So pi/6, what does this simplify to be? Pi/3, pi/2. Doesn't simplify, and it's just pi, right? Okay, we can go through it all. This next one down here is how many pi/6? 7 pi/6. And all we have to do is just keep adding it through. 7 pi/6. Now I'm going to simplify them as I go this time. 8 pi/6 winds up being 4 pi/3. That's the wrong spot. 8 pi/6 is 4 pi/3. 9 pi/6 is 3 pi/2. 10 pi/6, 5 pi/3. 11 pi/6 is not simplified. And then we wind up all the way back at 2 pi for our full circle. All we have to do is just add 1/6 over and over and over, and we get the entire unit circle for free. Is the unit circle as hard as you guys said it was? What's different? Did you guys learn it very differently last year, seemingly? Okay, so I'm also just telling you to remember it, though.
But you explained it.
But there's a way, like, okay.
You talked to us.
Well, good. I'll stop doing that. All right. So as we look at this, here we are. That's the whole unit circle, except I've missed some angles. How much of a half circle is this one? 1/4 of it. And it's weird. So I could say how much of a whole circle, and you could say, well, it's 1/8, but that's a weird way to do it. If we can remember that that's pi, that's 1/4 of it. So 1/4 of pi. How would we write this one? Oh my gosh, that's so nice. So here's pi/4. And I'm going to switch to red so they stand out a little differently. Pi/4. And then notice what happens. If I go another 45 degrees, this would be 2 pi/4 instead, right? Which it simplifies to pi/2, just like it just did. And 3 pi/4 and 4 pi/4. Because so 1 pi/4, 2 pi/4, every 45 degrees, I'm just adding one more pi/4. That didn't seem satisfactory. Check it out. I'll wait till you look up. 1 pi/4, that's 1/4 of the half circle, right? Here's 2/4, 3/4, 4/4. Now instead of adding pi/3, I'm just going 45 degrees each time and adding pi/4. So here's my 4 stops.
How do we do the down?
Down here? Yeah. Well, check it out. Here's 4 pi/4, right? Go another 45. And go another 45. Which simplifies to this. And 7 pi/4. And 8 pi/4. Yep. Yeah, no, thank you for asking the clarifying question. Okay. No pi/6, no pi/4, and be able to count down from 3, and you're golden. Okay. I want you to have it memorized for the quiz at least once, but again, I don't want you to have to check your sheets over and over and over as we go through all the trig stuff. You'll be okay if you have to do that, just so you know. But it sucks if every single time that you have to answer a question, you have to dig out your reference sheet and check it. Let's just commit to getting it memorized. Cool. All right. So with that, I have not even looked at any of the Precalc stuff that we're about to do. How are your weekends? Okay, fair. Anybody do anything super awesome? Fair. Okay, so our last class, we had a little bit of notes, right? And all we did was the unit circle, I think. And we just started talking about it, right? Okay, so today we're going to jump in and we're going to give ourselves as a little extension of that. We're still in 4.2, just so you guys know. Our first topic was the unit circle, which we've spent a whole day on at this point. Maybe 2 days, with that one day was weird because the video, whatever. Cool. Still continuing on, we're going to talk about the 6 trig functions. And you can just write trig. I'm going to write trigonometric functions. Okay. There are 6 different functions that we deal with, and you may or may not remember 3 of them from Algebra 2 or from geometry a few years ago. Do you recall any of the 6 trig functions? Cosine is one of them. Sine. Tangent. Okay, so here's the weird part, and I don't know why I do this, but we're going to define these much more formally. We're going to let t, or we can do theta if you'd rather. Do you want t for an angle or theta for an angle? Theta? Okay, so we're going to let theta be a real number and the point x comma y be a point on the unit circle, corresponding to theta. Now, it feels weird because notice I said let theta be a real number. And that might feel weird instead of me saying let theta be an angle. But the 2 pi, recall, it's just the circumference. So I'm just going some distance around that circle, which is exactly what an angle would do. I'm only going theta of that distance, whatever theta happens to be. So we have some angle or some real number, and I'm lining it up with a spot on the unit circle. We have 6 trig functions, and I'm going to write them very specifically. I don't know why I write them in this order, but I'm going to stick to it. The first one is we're going to write it actually out. We get sine. Do you guys remember the shorthand for sine? S-I-N. So it looks like sin, but we're not going to say sin, just so you guys know. I'm going to say sine is a real function, and it becomes sine, S-I-N, of theta. Now,
Is that a theta after the sign or is it an E? It looks like an E.
this?
No.
This is sine. This is a real word. Sine is S-I-N-E. And then it becomes this shorthand. Sine of an angle theta becomes sine, sin is what it looks like. And then this is the part that I really want to talk about. Just like we saw with log stuff. Do you remember what we refer to this as? It's the argument. This is the sine of an angle theta. That's how we say this. Now you could just call it sine theta. That's okay. But you can't just divide both sides by sin. It doesn't work. It's stuck together with that angle theta. So sine is one of them, and we're just going to define them all right here. If you give me the sine of any angle, it is so easy. This corresponds to some point on my unit circle. It turns out that sine is just the y value. That's it. Now, there's one little annoying thing that we're going to see, but we have sine is y. All right, so we also get another trig function called cosine. And do you recall the shorthand for the cosine? COS. Now, you will hear me call this cos, but cosine of an angle theta. And this one, I don't know why I do it in this order, and if I could go back in time and change what is naturally set up, I probably would. But sine is y, cosine is going to be something else. What comes first, C or S? C comes first, and what comes first, X or Y? So cosine must be the X values of that point. And we'll do a bunch of examples with these two to get the hang of it. Sine is Y, cosine is X. every time. Okay, we get another one, tangent, and I'm going to write these three very specifically here, and then I'm going to write three more over here, and I'm doing them in a particular order. What's the shorthand for the tangent of an angle? Tan. Now, I do want to show you guys, just like we did with logs, if I write this, is theta still the argument of my tangent? Yes, even though I didn't include the parentheses, it is still the argument. Pretty often you'll see me not put the parentheses there, unless they're necessary. Okay, tangent of theta. Remind me of that lie that I told you guys. Soka toa. And what is toa? So check it out. You don't have to draw this. I just want to think it out, okay? If you give me any bow tie and butterfly, and here's my angle theta, and it corresponds to a point up here that's x comma y. And I asked, what's the tangent of this? What's the opposite length? What's this side length? That's y over, what's the adjacent side length? So tangent is exactly y over x. And it turns out from SOHCAHTOA, you can remember all these. We are looking at these only from the perspective of the unit circle right now. We'll get to bigger circles later and not a whole lot changes. But for now, it's only on the unit circle. Okay. These three all feel familiar, I would imagine, either from geometry or from last year or from both. Okay. There's three more that I'm not sure if you've seen. If we talk about sine, have you guys dealt with the cosecant? Okay. Now, I want you to notice, and this is very intentional, we are defining this, and I'm writing sine, and next to sine is cosecant. It's weird that we're doing it, but there's a reason. Cosecant is CSC of theta. Does anybody remember how cosecant is defined? 1 over sine, but if sine is y, this is just 1 over y. But I agree with you. We'll see those definitions as well, Dolan, just so you're aware. Cosecant is just the reciprocal of sine. That's it. Just flip it. Okay, and it's weird because they switch, right? Sine and cosecant. We have cosine and secant that also match up. Secant, and that's SEC. And based on the location on which it's been written, this must be the reciprocal of what? Cosine. And if cosine is x, then the reciprocal is 1 over x. Good. So there is a good reason for it, although we're not going to go completely into it. These are the ones that are really linked. The sine and its cofunction, the tangent and its cofunction, like those ones make sense to name it that way. Why these ones didn't get switched the other way, I have no idea. Same thing, like I think imaginary is a terrible choice. Invisible would have been the better I choice for the invisible numbers because we're called them the imaginary because somebody is being snarky and saying, oh, we just made them up. They don't even really exist. They're imaginary. And then everybody's like, yeah, they are. And it bit onto it. Anyway, yep, there's a few parts in math that do that. Well, what's our last one? We have the sine, the cosine, the secant, the cosecant, the tangent, the cotangent. What's the shorthand for cotangent? COT, indeed. And if tangent is y over x, then the cotangent must be x over y. Now, as we go through here, the only thing that I'm not making us put down, because I want them to be just like implied all the time, could we say something can't be 0 here? What can't be 0 in this situation? Y. What can't be 0 here? X. So we're not going to write them, but we do recognize that, hey, there's some places where it makes us divide by 0. Okay, so here's where we're going to try our best without looking at the unit circle. So if you have the unit circle in front of you, here's what I want you to do. I know that you probably don't have it memorized yet, and that's completely okay. If you have it in front of you, just take it, flip it upside down. I don't want you to look at them yet. Okay, because we're going to try to think these out. And we're just going to do a quick example where we're going to try to evaluate the 6, and I'm talking about the 6 trig functions at theta. Okay, and really I only care about sine, cosine, and tangent for these, just so you're aware. because the other ones we get for free. So I might only do the 3 of them, and then we'll talk about it. So let's pick a theta here. Let's say I want theta to be a real number, and we'll say it is 5 pi sixths. The very first thing I want you to do, and if nobody can see their unit circle, that's awesome. From your perspective, here's 0. I want you guys all, on the count of 3, you'll think about it for a minute, but I want you to try to point your left hand to where 5 pi sixths is. 3, 2, 1, go. So I'm like right here. Okay, this point, without having to check my unit circle, it's really far over, right? So it's like I'm the 30-degree triangle, but on the other side. I'm really far to the right, or really far to the left, I guess, from that perspective. If all I'm thinking without checking my cheat sheet is if I'm thinking that I'm over here, and I'm just going to draw this out, because this is like legitimately what goes in my head. Here's my 5 pi 6. It's almost all the way there. This is further left or further up? Further left. So knowing that it's the furthest left we can get, is this a 3 or a 1? Root 3 over 2. And what's the corresponding y value? 1/2. This is what I think of in my head as I'm doing it. And it's what I want you guys to think of in your head eventually as we get there. You'll probably have to check your unit circle for the first few days, but this is the best thing that we can do. Try to get it and reason out how we can get there. So as we're looking at this, I can find this point. There's my theta. And the theta that we're talking about, just in case it's unclear, is some real number. And it's just, I've gone this far along the circle. And I've happened to go 5 pi 6 of the circle. Okay, so let's check them out. What's the sign of this 5 pi 6? And remind me, how do we find the sign? It's the x or the y? And it's the y value. What's the y value at that point? Boom. There it is. What's the cosine of 5 pi 6? Why? So remember, I think you're getting goofed up with sine and cosecant is what I think you're getting goofed up. If sine is the y, cosine is the what? X. So what's the x coordinate there? Negative root 3 over 2. And I'm just looking at this x value. That's all that we have to look at. And it's the reason that I want you to memorize the unit circle. Okay, the tangent. You will not see it on your unit circle. When we get to the point of taking a quiz or a test, I have no issue if on that cheat sheet that I gave you guys, we'll go through and we'll add all the tangents around your circle because they're typically not included. It's sine over cosine or y over x, right? If you took, and we'll do some scratch work here. If I tried to do y over x, let's do some scratch here. What's the y value again? So 1/2 over, and I don't really love it. So that's like 1/2 times negative 2 over root 3. And I get negative 1 over root 3. I wouldn't necessarily show all the scratch work. And that's negative root 3 over 3, right? Here's my tangent. And there's all the scratch work that goes into it. We don't have to do it all the time. Maybe there's a super handy kind of shortcut that also goes through the circle with tangents. Okay. If we get the sine, the cosine, and the tangent, do we really need to do the cosecant, the secant, and the cotangent? I'm going to say 90% of the time, no. But what I would like you guys to do for this 10% of the time right now is I want you to find me the cosecant, the secant, and the cotangent from these numbers. Use the definitions that we have and how they switch around. Let's get all 3 of the other ones, and then we'll only do the 3 after that. Cool. I'm going to pause it. All right, so you'll see a couple things when I'm looking at this. I have quit writing 5 pi 6, and I've just committed back to writing theta. It's a little bit shorter. This one, I did not show any scratch work here, but if you look on the board over here, I did the scratch work. Remember, if we have a radical in the denominator, we're just going to multiply by the denominator again, just to clear that radical. Now, if we look at this one, it's exactly what's happening. And I'm going to do some scratch work over here just to have it. But let's check. If I want to go from tangent to cotangent, I just flip it, right? So this becomes -3 over root 3. And what's a clever choice of one that I can multiply by to make it so it's not a radical downstairs? Good. And let's just multiply straight through and see what shakes out. -3 root 3 over, and there's a few ways we could write this. Up there I wrote the square root of 3 squared and said it was 3. But remember, this is also root 9, which is just 3, and now they're gone. And that's all that's happened. Cool. Doable? -√3. Okay. I have one more that I want you to do for me, and I'm okay with just the sine, the cosine, and the tangent. And you can use your unit circles, but I would encourage, try to think about where you wind up first. Like, try to do it, at least in your head, without the unit circle, and then flip it over and use it. Okay. Questions about any part of this before we move on to doing one more here? Okay, do you want to hear the brain rot term that I heard this morning that I don't think is caught on here yet? A choppelganger.
I've heard that one.
So no, this one's fun. Do you guys know what a doppelganger is? And to be chopped is not good, right? So it's like you're the Temu version of a doppelganger is what it is. And I kind of love it. Yep, I kind of like it. Chopple, like kids down south are saying it, choppelganger. And the guy that I get these videos from, he said, a kid walked into me and said, hey, you're the choppelganger for this person. And he said, yeah, I can see it. That's fair. I don't know. I get a kick out of it. All right. This one, I'm going to give you theta. All I want is sine, cosine, and tangent. I don't care about the other three. Theta this time is -2 pi thirds. -2 pi thirds. Say what? Cool. Talk it out. Try it out. We'll see where you wind up with. There is a very geometric approach to this problem where we think about the unit circle. There is a not very geometric approach where we don't think about the unit circle. Some of you, like, it's going to be split in here. If we want to think about the unit circle, I'm not going to draw the actual circle. I'm just going to draw this here, and we're just going to eyeball it. If here's my initial side, this is about a pi third. One of them, here's two of them. If you look on your unit circle in front of you, this will wind up at 5 pi thirds and then 4 pi thirds. Now, this is -2 pi thirds. In my head, I don't really like to think about going the negative direction because no matter how hard I look, there's no negatives on the radians on my unit circle. So what I do is I think about a nicer angle instead. I know that if I'm facing this direction, I can just turn how many radians to wind up in the exact same spot? 2 pi. So I'm going to say that this is the exact same thing as if I add any number of full circles, 2 pi. And I do this all in my head. I don't even have to look at the unit circle, and you'll get there. But I think that I get that this is 4 pi thirds as well. So whether I'm looking here and saying, oh yeah, I stop at 4 pi thirds, or I'm doing it here and saying it's the same as 4 pi thirds, we get the same answer. Now, I know that 4 pi thirds is all the way down here, which is further down than up. Sorry, further down than it is left, which means I think I know this ordered pair. What is this ordered pair? -1/2 and -√3/2. And notice, I'm just thinking about the down versus up situation, just like we did in that first quadrant. I don't really have the whole unit circle memorized, not exactly anyway. I just have to reason it out. Once we have that, these are super easy. The sine is the what value? The y value. So it looks like it's -√3/2. The cosine is the, which is -1/2 here. And if I did y over x, I'm going to wind up with just negative over a negative, which is a positive √3. Awesome. Okay. These things, the unit circle, I would keep it with you, honestly. Like, use it for the first few nights. But I would encourage, try your best to think about them without consulting your circle. The -1 was just me throwing you a curveball. Okay. For the next 15 minutes, I'm going to give you some stuff to work on. I want you guys to begin, and I'm going to type it here instead. What?
I just saw someone walking. I feel bad.
Where'd you guys go shovel?
Oh no, I think the kids shovel.
Oh, okay. All right. Today is the 12th. And tonight, can I just start? Do you want, I guess I should have asked this early. Do you guys ever care that I write this stuff that we did in class, or do you just care about the homework?
No, I want that because
You want this stuff that we do in class? Okay. Okay, so I'll add that here in a second. Tonight, though, your homework is going to be 4.2.1, page 277. And I want you to knock out problems 9 through 17, 23, 25, and 27. Now, here's the deal. I don't have a note written, but as I'm looking at it, if it asks you to evaluate all 6 trig functions, I only need you to do all 6 on a single one of them. The other ones, you can just do sine, cosine, tangent. Okay. Yes.
Oh, she has. I think it's gonna really? Yeah. I was told questions
Oh, sorry.